talking about how to use Jupyter Notebooks to launch simulation jobs on our HPC resources using AgavePy. So before we get going, a little bit of background information on DesignSafe, especially those of you who are brand new to DesignSafe. So DesignSafe has a vision, and our vision is that we want to become an integral part of your research. We want to become an integral part of your research discovery in particular. What we'd like you to do is be able to use some of the tools and the tools that we've given you, some analysis tools, visualization tools, data integration, and some simulation applications on DesignSafe for you to be able to, that enables you to do your research work. We want to be able to support what we call the end-to-end research workflow. That is, being able to conceive your idea, being able to generate your data set, and then be able to share your data set with other researchers so then they can then conceptualize a new idea and base their work off of your work and have the entire link from where the idea originated from to a final publication, all on DesignSafe. So a little bit about DesignSafe. We have been built as a cyber infrastructure that supports the natural hazards community. And what we want to try and do is enhance and amplify and link all the capabilities of the other NHERI components through the cyber infrastructure. So how do we do that? So DesignSafe has a bunch of little parts to it. One of those parts is the experimental research and the rapid research. And we provide what we call the discovery workspace for that research to actually be engaged. And then, of course, a simulation team can also work with those other teams as well. Everybody interacts with each other using the data depot. The data depot is essentially the centralized location for your data. What the beauty of it is, it has no set data structure. You can have your data in whatever format is most easy for you to do your research work in. And some of the tools that we give you in the data workshop allow for analysis and visualization. Also, there's a lot of applications created there, a lot of applications you can run. And all these applications are available to you to run using a Jupyter notebook as well. All right, so the idea behind DesignSafe is to build a community. All right, so the community that we've given, this community needs a way to talk and interact. So we've developed the Slack. We're using Slack as our communication tool. But Slack is a little bit more than just your typical tool. I mean, yeah, you can build teams, you can build different channels, which have like topics of discussion. But you can also tag keywords that will notify you when those keywords show up. You can also have private conversations with other researchers. You can build collaboration teams. You can share documents with one another. And for this webinar, we've actually created two webinar channels. One is the AgavePy channel, and one is Allocations channel. And we'll talk to you a little bit about what those are going to be used for. So one of the things I do on Slack is all the time is I create remind me messages. So I just say remind me in X amount of time to do something, and I build this entire to-do list. You can do site-wide searches on keywords. You can star messages up for follow-ups. And of course, you can do animated GIFs, which is kind of funny. You use the /Giphy command to see that. So one of the things we have on Zoom, if you notice, that Zoom does have a built-in chat window. So if you go up to your top and you click on more, there is a chat. The way these webinars usually work is we have the presenter giving their material and going through their slides and doing a demo. What we'd like you guys to do is be able to follow that demo along. If you have any questions, come to the Zoom group chat and ask your questions there. We have a couple of people at TACC on the chat right now who are more than capable of answering any questions that are coming up. And that way the presenter can go through her slides unaffected, and your questions will still get answered. So after the Zoom session's done, after this webinar's over, we've created those two Slack channels where we can continue the conversation. So after the Zoom's over, find your way to Slack, get on those channels and ask questions, and the TACC people will be on there to answer whatever questions you might have. Okay, so a couple little housekeeping items. DesignSafe, where to get started or where to get help if you're brand new to DesignSafe. Click on the help button. So at the top of it, there's a help. There's a frequently asked questions. There's user guides. We have a couple videos on how to get started. And if all else fails, you can always submit a ticket. Okay, so today's webinar is about launching numerical simulations using Jupyter. And then we'll also cover how to request additional HPC resources for your DesignSafe research. So first off, we're going to talk about a little bit about Jupyter Notebooks and how to launch those, where those are located at. Then I'm going to hand this off to my colleague, Julia, and Julia will talk about actually using AgavePy to launch numerical simulations in Jupyter. And then afterwards, we'll come back to me and I will finish up and talk about how you can request additional computing resources at TACC. Okay, so if you go into your into DesignSafe, we have the research workbench. Under the research workbench, we have the data depot, which I've already mentioned is kind of like it's a big file system, so everything looks just like a file system would. And then we also have the workspace. So if you click on workspace, it brings you to a couple of different tabs. Underneath the data processing tab, there is multiple items that are available for you to actually do some data processing and analysis. One of those is Jupyter. So if you click on Jupyter, it'll tell you that, hey, this is a web app, and click the launch button. This will bring you up in a brand new browser window. Go ahead and click login, and it will normally bring you up to either what we're seeing right now, which is stop my server or go to my server. There's also a start my server button. So if you've never been to Jupyter before, or if you've logged out your previous session, you'll see a start my Jupyter session. So I'm going to go ahead and go to my server now since it's already launched. And we will come to this landing screen. Now it is very important that any notebooks you create under the My Data folder. The My Data folder is persistent. This is actually where all of your files are located at. These are the exact same directories that you have in the data depot. So anything outside, so if we go to the home, anything you save here will not persist and will be deleted. So please go to your My Data folder to create any notebooks that you want to create. All right, so a little bit about what Jupyter Notebooks are. So Jupyter Notebooks are a web-based interactive computing tool. What's really cool about it, it allows you to do development work. You can document your program. You can execute your code. You can put comments in it. You can essentially build this thing as a working research paper. You can actually create a research paper on here, have bits of code that get automatically ran and updated to basically build an interactive research paper. One of the other things you can do in Jupyter Notebooks as well is you can create widgets, you can create graphical user interfaces to interact with your data. It's a very big encompassing tool. But it's really simple to use, which is why we've chosen Jupyter as being our primary tool for you to do custom development work. All right, so how do Jupyter Notebooks work? Well, so a notebook has an interactive session that's connected to a kernel, all right? And that kernel is essentially what programming language you want to implement or you want to use. That's basically the nuts of it, nuts and bolts of it. So if you go here to New, we can create, these are what's currently available to you, these notebooks. We have Bash, Python 2, Python 3, and R. I'm going to go ahead and click on a Python 2 notebook. And the first thing we come to is a coding screen. So the way these notebooks are formatted is you have a code cell and you have a markdown cell. The code cell is essentially code. So I can easily type, print hello world. All right. A markdown cell, if I go down here and create a markdown cell, so go ahead and run that. This one I'm going to go ahead and create a markdown cell on. I'm going to say cell type markdown. This is essentially a documentation cell. So I can put a comment here. The previous code previous line of code prints out hello world. So now what you can do is you can basically document your program as you're running it and what each line in your code does. What's really cool about these little markdown cells is that they support HTML. So you can make these as pretty as you need to be, or as you'd like them to be. Other things you can do in your markdown cells, you can make headings. So you can use the pound sign for a heading, double pound for a subheading. You can put ordered lists inside there. You can do a sub list. You can add other items. You can do, like I say, you can do pure HTML. And what's really cool is it'll even support LaTeX. You can actually put your equation in there in LaTeX form, say this is the equation that I'm trying to solve, and have that print out in your documentation. So the way the workflows kind of work in Jupyter Notebooks, at least how I suggest using it. So my father used to be as an aerospace engineer. He used to work in a wind tunnel, and he used to keep a log of all the experiments that he would run. And in that log, he would say, all right, this is the experiment I ran. These were the settings. This was the model that was in there and whatnot. So what I suggest how you keep your notebooks is have a laboratory notebook in mind. So document what it is you're trying to solve, your code, how you're going to solve it, what all the little bits of your code does, and then execute it. The joy of it is this now looks just like a traditional paper notebook. You can hand this off to somebody else. Somebody else can then look at your notebook and have a clear understanding of what it is you're trying to achieve and how it is that this notebook runs. There's some shortcuts. There's Shift-Enter. So when you put in a cell, like my print hello world or any other line of code, Shift-Enter will automatically execute that line of code. Control-Enter. Control-Enter runs that line of code, but then keeps you in that exact cell. So if you notice, this cell ran, but it didn't move me to the next cell. So also a nice way of running it. Alt-Enter, it runs a cell, then inserts a new one below it, and then you have Escape and Enter to move between Command mode and Edit mode, very similar to how VI is set up. So we just showed you how to launch a notebook through DesignSafe. Go to the Workspace bar under Data Processing and hit Launch. So with that out of the way, I would like to introduce you to Julia Looney. Julia came to TACC back in 2017. She's a Python developer with our cloud and interactive computing team. Before coming to TACC, she worked as a web developer at the Technology Resources at the University of Texas here in Austin. And her primary coding language is Python. And that's what she loves to do, is learn new bits about Python. Because everybody out there, if you guys are Python programmers, you know there's always something new to learn when it comes to coding Python notebooks. And of course, just like the rest of us here at TACC, we're all nerds, we're all geeks. What we love to do is learn more things and talk about the things we love to learn. So Julia really enjoys attending and speaking at Python-related conferences. If you have any Python-related conferences, contact Julia. She'd love to come and give you guys a talk about it. All right, with that, I'm going to hand this off. I'm going to stop sharing my screen, and Julia should be online and ready to share hers. I'm going to transfer this over to you, Julia. Thank you.
Great. Thanks, Charlie. So I will begin sharing my screen here. Can you hear me all right?
Yeah, I can hear you great. Thanks.
Great. Okay, so thank you for the great introduction. So what I'm going to share with you all now is some of the basics of using AgavePy. So with the Agave platform, it's kind of a way to use Science as a Service APIs. Some of you might be familiar with it, but it's also a really great utility for the Jupyter notebooks. So we'll start with importing AgavePy. So to import AgavePy into your notebook, you do from AgavePy dot agave import agave with a capital A. And so, you know, from here we've imported the library. So next, in order for us to actually use the Agave client, we will need to instantiate a client. And to do this, Agave needs some credentials. And so typically that's done using OAuth and some little dances around that. But we have, since we're logged into Jupyter Hub with credentials already, we can bypass some of that by instantiating our client using agave.restore. And so doing this will use our Jupyter Hub credentials to instantiate an Agave client for us. And here I'm just calling our client AG, so the client will be stored in the AG variable. Okay, and so from here we have our client, and to kind of show that it did actually successfully get our client set up for us, this is kind of a neat thing. So if you do ag.profiles.get, you can see here that it did successfully get my information to instantiate that client. So another thing that you can do with this client is we can just see, by using the dir function, we can see what is available to us from this client. So here we can see that we have apps, files, clients, jobs, all of these things that are here available for us to use. And so for this webinar, I'm going to focus on apps in particular. And so if we want to see what we can do with apps, we can use this dir command again and kind of just take a look at what's available to us if we want to look at apps. And so here we can see we're given we're given this list of these methods that we can run for an app, for the apps of our client. And so just to kind of see what we have here, we can use this list method here. So if we do ag.apps.list, we can see this long list of apps that are available for us. And so what it will return here is what's known as JSON. And if you're not familiar with that format, it's essentially a list of Python dictionaries. So here we can see we're given this list, and there's all these dictionaries in here for each app that is available to us. So before moving on, let's take a little bit of a recap here. So in order for us to instantiate our AgavePy client, we first had to import Agave, and then we had to set up the client using restore, which will automatically use our Jupyter Hub credentials to set up the AgavePy client. We can check our profile on the client, and then we can see what features are available to us, both on the client itself and for the apps on the client. And then we can get this list here of all of the apps available to us. So next, we're going to take a little bit of a deeper dive into what we can do with apps. So just kind of, since you know this, we have quite a long list here. Just as an example, I'm going to just pull out the fifth item in this list. So here I'm doing ag.app.list, and I'm just going to get the fifth element of that. My apologies, it should be apps. This is a function, so make sure you remember the parentheses there. So this, so here I've grabbed the fifth item in this long list that was given to us here. And if we take a look at that, we can just see the dictionary that's returned for just that app. So here we can see that this is the OpenSEES app, and we can get some information about it, as you know, which revision it is, what version it is. We get a nice description, and we can even use the dictionary. We can pull specific items from that dictionary as well if we don't want to see it all at once. So the ID of the app is unique, and it's what will help uniquely identify apps in the AgavePy client. And so another thing I wanted to point out before we get too far is, so say you forget one of the functions that is available. The AgavePy client also has autocomplete. So, and I think the screen share might be preventing that from popping up, but it will also, I'm sure if you try it on your own notebooks, you'll notice that it does have the autocomplete functionality there. So we can also retrieve this app if we know its ID. So if we knew the ID of the app beforehand, we could use ag.apps.get and then app ID equals, in this case, we have the value already here. And so then this will actually return the full app. And I realize this is quite a lot of information that it returns. And for the sake of keeping this within a reasonable amount of time, I'm going to point you towards the documentation for if you're wanting to learn more about what you can do here with the full app. And so I'll leave this here, there actually is quite a lot of good information available for AgavePy. So just to kind of give a brief review on that. So here we can pull a specific app. We can get the ID of the app, and then using the ID, we can pull information for the full app. In this case, for this example, we're using OpenSEES. So now that we know how to get a full app, we can let's actually create a variable that contains this full app. So here we do the ag.app.get, and then the app ID equals the ID that we have up there. It is apps plural. Sorry about that. So now we have, if we look at that, we can see it's just as what we got up here before. We have the full app, and we can see various things from here. And so we don't have to dig through this huge dictionary that returns here. One useful thing that we might want to see from this full app are the inputs that it requires. So if we do full app.inputs, we're again returned this list of dictionaries for all of the inputs that this app will require. And it will contain information such as a description and anything else that would be useful for you there. And so another thing that you might be wondering how to do is, say I wanted to search for a particular app. Instead of wading through that long list of apps, I might want to just search for one. So you can grab an app by searching for it in several ways. So first, if we do ag.apps.list, so before that gave us, obviously our big list of apps. But we can also pass this list function some criteria. So in this case, we're going to pass it a search variable, which will be a dictionary. And we can say, okay, I want to search by the ID. And I'm going to pass it the ID for the app that we've already picked out. And so here we, instead of searching through this list, we can give it a specific ID and get an app from that. Or if you're not entirely sure what the full name of the app is, we can do, instead of searching by a specific ID, we can search by name.like, which will find a name similar to what you provided. So in this case, we're going to type OpenSEES, and then I'm going to put a wildcard character after that, so it will return all of the apps that contain OpenSEES and then something else afterwards. Okay, so here we can see all of, it's returned to us, instead of this specific version with this specific ID, it's returning us all of the apps that contain OpenSEES in its name. And so what it's going to return here are just multiple versions. So we can see, we've got this version, and then we've got this version. And so this can be helpful if you want to kind of see what versions are available for a particular app. And then if you would like to do a search for a particular version of the app, you could do ag.apps.list again, and we're going to pass it another search like we did before. So again, we're going to do name.like, and then OpenSEES with the wildcard character. And then we're going to pass it, we're going to add to this dictionary and pass it another criteria. So in this case, we're going to filter on the revision. And we want it to be greater than, which is GT, or equal to, which is the E, and then let's say 2. And so then this will exclude, so previously we got this version here that was revision 1, and so now that will no longer show up. It will only show those that are at least revision 2 higher. so just to kind of go over that again, so we talked about how we can obtain information on the full app, and I also showed a bit how you can see the inputs for the full app, which is useful later when we go to run the app. And then we also talked a bit about how you can filter a list of apps to get the specific one that you're looking for, and that can either be done by passing it an exact ID or just a name with a wildcard character to return all that it finds with that criteria. And we can even filter on a specific revision or version or any of these criteria returned in the dictionary. And so I'm going to take a little pause on that, let that sink in a bit. And then next we are going to talk about how we can run an app using what we've just learned. So to do that, I'm going to actually create a new notebook, and we've been using Python 2 for this. Okay, and so for this next part, you'll see again some of the things that I just mentioned in this new context. So just like before, we are going to import Agave. And then also, just like before, we are going to instantiate our client using restore. So here we have our Agave client once more. And then, so next we're going to select our app that we would like to run. So in this case, we're going to search for it just to make sure we find the version that we are wanting. So again, we do ag.apps.list, and we're going to pass it a dictionary that it will search by. And we're going to do name.like, and we're going to search for things that are like OpenSEES. Okay, and so here we return the list of all of our apps, and today I'm going to use this version in particular. And so once we can select an ID that we want to use here, and then we can set that as our app ID. So in this case, since I'm selecting the first one here, I'm going to reuse this bit of code here. And so this returns a list, and I'm going to grab the first one in that list. So now we just have this one app for OpenSEES. So let me go over that once more. So first we imported Agave, and then we created our client just like before, and then we searched for all of the OpenSEES apps, and then we decided that we would select the first one here. So we set our app to the first object in that list. So next, before since now we have our app, before we continue, it's important that we look at the inputs that this app is requesting. So we have our app, and we're going to do app.inputs. Sorry about this. I think actually, one moment. Okay, I think so. An alternative way, I think this might not be the best way. An alternative way is we can also, and we talked about this in the last notebook, to pull a particular app, we can get the app ID, and then in this case, I'm going to set it to this variable here as a string. And then, and you might remember this from before, we can do ag.apps.get and then set the app ID to the ID that we just set in the last cell here. So just to kind of review what I did there, an alternative way to grab an app is we grabbed the ID from this object in this list. We set it to this variable app ID, and then we can use ag.apps.get and set the app ID to that particular app ID. And as you can see here, it's it's returning the full app now. Before we didn't have the full app, we just had the regular app. So now we have the full app. And now that we have the full app, we can check the inputs, just like we did before. So here, it returns a list of dictionaries of the inputs, and we can see here that we can see that it only requires one input. And another thing that we should check before running our full app is the parameters. So just like the inputs, we do app.parameters. And here, we're returned a list of dictionary objects that specify the parameters that are required for this app. And as we can see, again, there's only one. And so next, in order for us to run a job with this app, we will need to create a job description. And so this is a dictionary that has several attributes, and I'll go through all of those attributes. Okay, so here we have our dictionary. And so first we have the job name. And this is just the name of our job. It can be anything, really. It can be anything that you want it to be. And then the next value after that is the app ID. And that is just the value that we retrieved previously. I'm not going to scroll up that high, but we saved it in this variable app ID. And alternatively, you could just type it out. And then next we have execution system, and that is the system where we will be running OpenSEES. So an example of that would be, I'm just gonna, would be this location here. And then the next parameter is batch queue. And this is the queue that it will run in. And so since this is just a test, I'm going to run it in debug. And then node count is how many nodes on the execution system we want to use for this job. So in this example, I'm just going to use 1. And then we have processors per node, which in this case, I'm also going to just use 1. And then we have memory per node. And this will specify the amount of memory per node in gigabytes for this application to run. And so I'm just gonna do 1 there as well. And then we have we can specify the max runtime. And this will, as you guessed, will specify the max amount of time we want this to run. And so as an example, I will just do 30 minutes. And then there's the next attribute, archive. And what this specifies is whether we want Agave to archive the outputs back to our storage system when it's done. And so if we do want that, then we would make this value true. And then we need to specify retries. And so this will specify how many times we want Agave to retry the job submission if it fails. And so as an example, I'm going to put 0. And then we have, next we have inputs. And this ties in with the inputs that we printed out here. And so for this, we will provide a dictionary describing the inputs that we want to use. So the dictionary should have 1 key for each input, and the key should be the input's ID attribute. So in our example here, we have this input, and so then down here we will provide a dictionary for that our 1 input that we have, which is called input directory. And then we will pass it a list, in this case, with the location of that input directory. So I'm actually just gonna paste this in here. Okay. And then we also have parameters, which is the other value that we figured out right here. And similar to the inputs, we will provide a dictionary with a key for each parameter. And the value's type depends on the parameter. So in our case, we just have one parameter with the ID input script, and so the value will just be a string with the name of the file. So here, I'll show you an example of that. So here's our dictionary, and input script is the name of our parameter, and we're going to pass it a example script. And so those are all of our parameters that we need for a job description. And so the job description will be sent to the AgavePy client for our app, and it will run a job. It'll run the OpenSEES job with these parameters. So let's take a quick review. So first, the first step that we took when we want to run our OpenSEES app is we found the version of OpenSEES that we wanted, and then we got the full app with the get method, providing it the ID that we got back from our list. So then with this full app, we were able to look at the inputs that were required, and we were able to look at the parameters that were required. And then from that, we were able to set up this job description here. And I have a typo. Okay. So I'm gonna pause here, and I'm gonna let this sink in a little bit. And just to review a bit, the job name is the name for the job, and it can be anything you want it to be. The app ID is the ID of the application. That can be either, we set that in a variable up here, but you could also provide it with just the string. Just I'll do that just so we can see what that is. And then the execution system is a system that where we're running OpenSEES. The batch queue is the queue that we want to run in, and since this is just a test, I'm using debug. The node count is how many nodes on the execution system we want to use for our job. Processors per node is how many processors we want for each node. The memory per node is in gigabytes, and that's how much memory we want to allocate for our node. The max runtime is the maximum amount of time we would want this job to run. If we want to archive our outputs back to our storage system, then we would set archive to true. Retries is how many times we would want the job to retry if it encountered a failure. And then the inputs and parameters are dictionaries that whose keys are the values that we got from when we checked out the full app and saw what parameters and inputs it required. So from here, we can submit our job so for this, we're actually going to create a new variable called job, since it will actually create an object that will contain the job information. And so then we do ag.jobs.submit, and the body will be our job description that we just provided up here. And for the sake of time, I'm actually not going to run that here, but I encourage you to test it out and see see what happens. And the cool thing from here is we can also check on the status of our job using another Agave library. And so this library is called Agave Async. So we're going to import that next. So from AgavePy .async, import Agave Async response. And so this package is really neat because if we create an object, an Agave Async response object, we can pass it our client and our job that we created here. And then with that, we can use this async response client to test or to see if our job is done. And so this will return true or false if our job is done. And then we can also see the response or the result of our job. So once our job is done, we can check the results. And so this will return something like finished once it's done. So to recap a bit on this, once you're ready with your job description, you can set up a job and submit your job using the AgavePy client with that job description. And then if we want to check on the status of that job, we can import this Agave Async response package and instantiate an object using our client and our job that we created. And then from there, we can check if it's done, and we can check the result. So that is my beginner basic overview of submitting a job using AgavePy. Hopefully you found that useful. There is great documentation for AgavePy, and I encourage you to look at that if you're interested in using AgavePy. And those of us at TACC here are also happy to help you with whatever AgavePy needs you have. So I'm going to pass it back over to you, Charlie.
All right. Hey, thank you very much, Julia. That was awesome. I appreciate your time and effort into doing the webinar for us. All right. I'm going to go ahead and share my screen and talk about how to get extended allocations for your DesignSafe project. So let me go back to my screen here. All right. Can everyone see that all right? So what you're looking at is Stampede 2. So Stampede 2 is our featured HPC resource that's available here in our data center. It's a pretty massive machine, and it's a very impressive machine. It's got a lot of cool hardware in it. We have almost 18 petaflops of peak performance. We have like 4,200 Intel Knights landing nodes. Each of those have 68 cores available to it and 96 gigabytes of RAM. And we also have about 1,700 Intel Xeon Skylake nodes, which are the brand new ones which are coming up. Each one of those have 48 cores on it with 192 gigabytes of RAM. So we got this. So we're looking at about 6,000 nodes available to you. We have 2 high-performance Lustre file systems. So Lustre file system is a parallel file system that allows files to be written and read in parallel. And then, of course, we also have access to our global shared system there as well. So Stampede is a very awesome resource that's available to us here at DesignSafe. So how can we allocate something besides just what you're given when you first create your DesignSafe account? Well, when you have your base allocation, when you first sign on DesignSafe, you are given 8,000 SUs, and a little bit more about what SUs are. SUs is basically the unit of measure we use to keep track of how much processing power is being used. And we also give you 50 gigabytes of storage on our system. That's roughly what we kind of figured you'd be using in about during 1 year of using a single processor core. And that base is given automatically to everyone. All right, so if you need something beyond that, you actually have to go through an allocation process. And I'll briefly tell you what the allocation process is today. So first off, who's eligible? Anybody who's essentially a project PI on DesignSafe can be eligible for it, a PI being a primary investigator. You can also be an NSF graduate student researcher fellow, which is a little bit different than just a graduate student. You can read more about this in our allocation policy. You can be research staff employed by the federal agencies, state education offices, organizations. You can be a teacher or an educator with an accredited public or private K-12 school. Independent museums, observatories, libraries, research labs, professional societies. Anybody like that, you can become a PI on DesignSafe and request additional resources. Any of the commercial organizations in the U.S., small businesses. DesignSafe is really trying to focus on this right now, is getting small businesses to be able to put their data on DesignSafe and use the DesignSafe data in their research work. All right, so a little bit about the units of allocation. So what we have an SU. An SU is a service unit, and that is really, when it comes right down to it, it's basically how much one single processor can do on a wall-based clock time. That's what a service unit is. There's also compute time. So compute time is charged on the runs that you make on your jobs using Discovery Workspace or using a web interface or the Jupyter Notebook or direct command line on DesignSafe. There's also storage. So storage is charged by the gigabyte year. That's essentially 1 year of physical storage. So if you have a gigabyte of data sitting on our physical storage for one time year, that's what we have. I just see a question that popped up about international universities. Yeah, you can be international. The way international, or to be a PI with an international organization, you have to have some sort of affiliation on your team with a US-based research or institution. And then, yes, you can ask for additional resources on an international level. All right, so how do you apply? The best way to apply for the DesignSafe additional allocation is through a help ticket. TACC has, on our own portal, you can go through and you can request an allocation, but a special allocation process has been created for DesignSafe users. So it is best that you take advantage of that DesignSafe access. So you can fill out a help ticket. You'll need to include information about your eligibility, a description of the research that you want to perform, as sources of support, financial support, where this is coming from, and a justification for how many SUs that you've requested. So you can talk about a little bit about the project. These are a little bit about what the type of allocations that are available and what the size limits are. So we have 4 types of allocations available. There's a base allocation, a startup allocation, the research allocation, and educational allocation. The base is what we've already talked about. You have 8,000 SUs and 50 gigabytes of storage, which is approximately a single processor core for 1 year. A startup allocation, so we're targeting new users who are trying to explore what DesignSafe can do for them. Basically, startup allocations, you have a fast track internal review, which means our internal review process is pretty quick. And you can request up to 50,000 SUs and 1 terabyte of data storage. A research allocation, the max size there is 2 million SUs, which is 10% of the annual capacity of the system. So you can do 2 million SUs and 100 terabytes of data is what we suggest for that. There is no mandatory maximum size, but that's kind of what we have a suggestion for. And it's really aimed at people who are trying to do production-based research on an infrastructure for their goals. And this is subject to a research allocation is subject to a full review process. So we actually have a board of reviewers here that will take all these allocations, review them, and then get in touch with you. They might get back in touch with you and ask you additional questions on where you have to say, all right, this is what the SUs are going to be used for. This is what we're planning on doing with it, whatnot. There's also an educational allocation. and that is about 150,000 SUs and 1 terabyte of storage. This is if you're trying to use DesignSafe in your classroom, this is the best access point for you to go through, is do an education allocation and then be able to set all your students up to use your allocation setup for educational purposes. So each one of these are provided usually through the NSF, so there's no direct cost to the end user. However, if you're curious what the costs are, storage is available for approximately $100 per terabyte per year, and compute time is available at 0.0125 cents per core hour. So you can calculate how much time it is you're going to require and just go through and multiply by what that core hour is, and that's approximately what the service rate will cost you. There is, like I said, there's a review criteria for additional allocation proposals that are not fast-tracked for the research proposals. We're going to be looking at the scientific merit and significance of the experiment, of the proposal. We look at the methodology and make sure it's appropriate for the DesignSafe resource that you're wanting to use. We're looking at prior allocations or existing allocations and see what your success rate has been there. We also look at other use of other NHERI-funded facilities. And any funded support for a project that's not required, but preference is given to NSF-supported projects and NHERI infrastructures. And a startup allocation. So you can take a startup allocation to do a proof of concept and then use that as part of your criteria to get a research allocation. If you have any other questions about the allocation policy or in details, there is actually, on the allocation policy itself, there is a detailed format that you can follow to write up your policy. You can follow that through. The policy is available at this website, which is DesignSafe-CI, User Guides Allocation Policy, which is actually underneath the help. If you go to Help, User Guides. Once again, you can find us on Slack. There's a webinar for AgavePy. So if you have any questions for Julia there, she'll be at that channel and monitor and answer any questions you might have. We also have the webinar for allocations that you can ask any questions for there. If you have general questions or general use about DesignSafe, feel free to hit us on the general channel on Slack. You can also email us at training@DesignSafe or fill out a help ticket. I really appreciate all of you joining us today for this webinar. Thanks for sticking around. I'd like to give special thanks to Ellen and Tim and Jamie and Dan as our PIs on this project. Also, Julia Looney, thank you so much for covering AgavePy for us. And I'm not sure if anybody took advantage or not, but Joshua Yorte was sitting on our chat channel answering questions. And Josue is always behind the scenes because he's the guy who designed most and wrote most of the code for this DesignSafe portal that you guys are using. All right, I really appreciate everybody coming in today, and stay tuned for our DesignSafe training channel, and the next DesignSafe webinar will be announced soon. Thank you so much. You guys have a great day, and we'll see you next time.